joining. So I'm sharing the screen. Right. Um, can you all see the screen? Hello, can you all see the screen? Now you need to talk, right? Hello? Right. You got to speak. Right. Okay. Now we are discussing the double award paper, usual paper, the oral paper in Edexcels. We are starting off with 2024 May 17 paper. I wish that you all have the answers with you, right? Okay. Now I want you to speak up, uh, unmuting yourself, because otherwise then only we can have productive session. Right. Now the box gives the names of some substances, right? They have given us some substances, and complete the table choosing a substance from the box that matches each description. Each substance may be used once, more than once, or not at all. A good conductor of electricity. Out of these, what is the good conductor? Yeah, what is the catch? What is the answer? A good conductor of electricity. Out of these, huh? Okay, water conducts electricity, but still pure water does not conduct electricity, right? Water does not contain ions, right? Water, usually the normal water we have, right? It contains ions. That is why they are conducting electricity. But still, water is not a good conductor, right? But our mineral water, the water that we used, it can contain ions, right? So mineral water conducts electricity, but still it is not a good conductor. Now, out of these things, what is a good conductor? What is the catch? Huh? Usually, metals are conducting electricity really well. Metals, right? So, out of these, what are the metals? Tell me. What is the metal? Lithium is the metal, right? Very good. So, you should know your the first 20 elements in your periodic table, right? Right. Lithium is the answer. That is the catch. Lithium. Right. Second one, an element that is a liquid at room temperature. Out of these elements, uh, uh, a liquid at room temperature, an element that is a liquid. Now, it is always between iodine and bromine, right? Iodine, chlorine, you have bromine also there, right? Iodine is I2, bromine is Br2. So remember, bromine is a liquid, an element at room temperature. An element that is a liquid, it is bromine. Right. Next one. A substance that can be used. What about iodine then? Iodine is a solid at room temperature, right? A substance that can be used to form a yellow polymer. Form a polymer. Substance that can be used to form a polymer. What is the answer? What is a polymer out of these? Polymers are ethene, right? Ethene. Ethene through polymerization, addition polymerization you are learning. Ethene, when this is the ethene, once it is get polymerized, you get the polymer form called, this is the polymer, right? Right, this is the form. Once you polymerize it, you get this, right? Poly Polyethylene, right? Polyethylene, polyethylene polymer, polythene, polyethylene polymer. Yeah, so it is ethene, a substance that can be used to form a polymer. Polyethylene can be made using ethene. Ethene is the answer, right? An element that forms a basic oxide. What is meant by basic? Yeah, basic means uh, alkaline. Hmm. Okay, there's a slight difference between, you will learn in the A levels, there's a slight difference between alkaline and basic. Still the same thing, right? Potato and potato, still the same thing, but it's like there's a small difference. Alkaline and basic, right? So these two words are different from each other, basic and alkaline, right? So alkaline means, right? Alkaline means it is about a solution. Alkaline is about a solution, right? Alkaline solution. Basic means it can be a solution, it can be a solid, or it can be a gas, right? So both tells the same thing, but alkaline is about a solution, right? So alkaline means when you talk about a pH, what can you tell? Alkaline pH means what? Alkaline pH, what does it mean? When the pH is more than 7, we call it as alkaline. When the pH is more than 7, right? When the pH is more than 7, we call it as alkaline. A substance that has a giant covalent structure, right? A substance that has a giant covalent structure. Out of this, what is the answer? Diamond, right? Diamond has a giant covalent structure. We actually call giant structures. That's another term we call. What do you call? Giant structures are called, we call them as lattices also, right? Lattice. It's a lattice, giant lattice, right? So it is diamond. Diamond is made out of which element? What is the element diamond is? Carbon, right? Carbon. Carbon has now diamond is one polymorph, carbon element. There's another polymorph of this. Polymer means it is made out of still carbon, pure carbon. Huh? Okay, tell me a polymorph still made out of 100% carbon. Can you tell me another? Uh, Graphite, very good. Graphite. Two different structures made out of pure carbon, but the structure is kind of different, right? So yes, a giant covalent structure, it's a diamond, right? It is made out of covalent bonds. You are learning about covalent bonds, right? Ionic bonds and covalent bonds. What is the difference between the covalent bonds and ionic bonds? Very good. Covalent bonds are formed when the electrons are shared between two atoms. Remember, bonds are always made between atoms, right? Just like us, always it is between, bonds are formed between two atoms, right? So these electrons are shared between two atoms. That is called a covalent bond. Then what about ionic bond? What is an ionic bond? Ions. So electrons are completely taken or given off. When the electrons are completely given off, what do you call it? When an atom gives off electrons completely, what does it become? When an atom completely a cation. When taken electrons completely from another atom, it is called what? It forms a ion. What is that ion? When you have more electrons, it's called anions. Cations and anions. Right. There's another one. It's been covered a bit. Describe a test for chlorine. Not just one test, but in your O-level syllabus. Uh, you are given 2 marks for this. 2 marks means you must write 2 points, two highlighted points, short and sweet. Few words, two sentences. You are getting 2 marks. Tell me 2 points now. Hmm. Tell me one thing. Describe a test for identification of chlorine. Chlorine means so remember chlorine means they are talking about chlorine gas. They are talking about chlorine gas, Cl2 gas. Yes. Litmus paper. So you must write 2 points to get two marks. What are your 2 points? Your answer is correct. How are you going to get 2 marks for this? Yeah. Hmm? How do you break the answer into 2 points then? Okay, so what are the 2 points? Can you break your answer into 2 points now? I always ask you to write in point four. How do you write your answer in 2 points? Break it into two. What is the first point? Uh, okay, it's a long answer. Now, if I were you, I would answer like this, right? I will use a litmus paper, right? A blue litmus paper, a damp blue litmus paper. 1 point. It must be a damp means what? It must be a blue litmus paper. Wet blue litmus paper. First point, wet blue color litmus paper. Otherwise, it won't work. Next point, that the litmus paper will bleach, right? Will bleach. It will bleach. What do you mean by bleach? Bleaching means what? What is meant by bleaching? Yes, bleaching means turns white, right? Blue into white color. Okay. So there you have your 2 points, right? So you will get marks either you write a blue litmus paper or just a litmus paper, right? The thing is the paper is turning white color, right? Okay. But when you are doing the experiment in the lab, this is your test tube. Let's say you are having a solution and the solution and you are doing a reaction here and the chlorine gas is released when the reaction is happening. What you do is you take a glass rod, right? Okay. And you put a drop of water here and you put the piece of litmus paper on this edge of the glass rod, and you leave it over here, keep it over here, hold it like this. This is how you do the practical. Here you have the wet litmus paper. Now if there's a gas is released, right? Chlorine gas actually cannot be seen. It's a very light green color. Light green color cannot be seen actually from the naked eye. It will get what? Bleached. Since you are using a blue color litmus, it may change sometimes. Blue into what color? It might change when you are doing the practical. What will happen to blue color then? Hmm? What will happen to blue color litmus? Chlorine gas, remember, chlorine gas is acidic, right? Chlorine is acidic gas. So therefore, chlorine gas will turn the litmus paper first into a red color, blue into red color will get bleached. But you don't need to write about turning into red color, right? But when you're doing the practical for real, right, it will turn into red and the red color will get bleached. Any questions, Putala? Anything? Hello? Any questions? Okay. We'll move on to the next one. This question is about the reactivities of metals. The table shows the reaction of four metals P, Q, RS with water and with dilute hydrochloric acid. Right? You have four metals, they are reacting with water and with dilute hydrochloric acid. You have these metals, right? Just imagine you are doing the practical in the lab. You have these PQRS metals, but you don't know what they are. So you label it as PQRS. And you reacting, and the reaction is water, no reaction. Hydrochloric acid, no reaction. Very fast, uh, not done, they are not doing anything. Space, no reaction, R, slow reaction with dilute hydrochloric acid. S, with water, very slow reaction, a fast reaction. Okay. Um, right. Deduce the order of reactivity of the metals. Most reactive element, right? The most reactive element, will it react with water? Most reactive element? Yeah. So let's see. Let's scan through. Um, right. No reaction. Very fast. Not just reacting, it is reacting very fast. So now here they not done. Why they haven't done any reaction here with hydrochloric acid? Very fast with water. Why they have not done any reaction? Can you tell me? Very good. Could cause an explosion, right? It's a safety precaution because you know it is reacting faster. That is enough for us to identify what the element is. Very fast reaction. It is Q. Can you give an example for this? What could be this Q? Hmm? What could be this Q? Magnesium is reacting faster with water? I don't think so. Mhm. Potassium, sodium, they are reacting faster. Right? Potassium is reacting very fast. So they are telling about potassium. Higher in the reactivity series, right? You have it at the top. Right. Okay, then may react with water, but slowly, slow reaction. What is the answer then? Next space is for what? Reacting, but a slow reaction with water. What should be the next space for? S, right? These are not reacting. S is the next one. S. Good. Next one. Now let's cut it out. Very fast reaction, slow reaction, between R and S. Which one is the most reactive? Between P and R. R, right? Because this is not reacting, it's inert, right? Not reacting at all with any of these. So we can tell, you go with Q and, no, you go with the slow reaction, R and then P. Right? R, P. Okay, that's order. Am I correct? Yes, no reaction should be the least reactive. Give the letter of the metal that could be zinc. What is zinc? Uh, right. Hmm. That could be zinc. Yeah. Okay. Now it cannot be Q. It is reacting faster. S is zinc. Is it reacting with uh, S? What is this? Slow reaction. Is it reacting with water slowly? Zinc. What do you think? Zinc. Will it react? No, it won't react slowly, right? Not zinc is not reactive with right with water. Even slowly, it doesn't react, right? So then, what should be the answer then? It should be R, slow reaction with water. It's a kind of tricky one, right? It is always between these two, and even one could even tell whether it is P or not. So that is why you must memorize few things. With other than otherwise you can't answer it. Definitely, it is not this one. It is not reacting faster, and zinc is not reacting with water at all. So between this kind of tricky, right? Slow this one, slow reaction and no reaction. Between this, it is kind of a tricky one. Then how do you know whether it is the answer? You must study the reactivity of the few elements that is given to you. Should be R. Kind of tricky, right? Every paper has something like that, which is R. Give a word equation for reaction between aluminium and hydrochloric acid. Word equation. Easy, right? One of you please tell me the word equation. Uh, yeah, can one of you tell me word equation? Aluminium plus hydrochloric acid gives aluminium chloride plus hydrogen. Right? Okay, actually we are releasing a hydrogen gas. Right? They are expecting only word equation. Can right? They haven't asked about the what? Not the word equation with the symbols, right? Can you write and send it to me in the group? And send me a picture. Not the word equation with the symbols, with the formulas. Can you write the answer, the balanced equation for this, and send me in the group, either private message or either on the group itself. Can you do it now? Not the word equation, right? Let's see whether you can identify the correct formulas and whether you can balance it properly. Can you do it? Send it to me in the group. Okay. You got an answer. Ah, 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 ah. No, 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 no. This is not the answer. Aluminium. What is the valency of aluminium? Valency means number of bonds it can form, number of electrons it can share, remove, or take. Valency. Aluminium valency is equal to group number. Aluminium is in which group? Huh? Now you know the products. Aluminium, okay. Aluminium is what in the room temperature solid. Hydrochloric acid. HCl, right? Anyone knows, even middle school. Aqueous. Aluminium chloride is kind of trickier for you now. Let's see. Hydrogen is what? Hydrogen gas. Now here this is aluminium chloride. Aluminium is there. Chlorine is also there. Aluminium here, let's write. Chlorine here, let's write. What is the valency? Number of bonds it can form. Number of electrons in the outer shell. How many electrons are there? Hmm? Aluminium. Aluminium found in which group? Which group do you find aluminium? Aluminium is in the third group, so its valence is 3. Chlorine, group number 7. So therefore it can take another electron and obtain 8 electrons. Stable electronic configuration, octet rule. So therefore in chlorine, valence is 1. Now you share it. Huh? So therefore when you swap the valencies, what do you get? AlCl3. Okay. Remember now aluminum chloride is also salt. Metal with an acid forms a what? Methyl will acid gets neutralized. It's not a neutralization reaction, it gets neutralized. You are getting a neutral salt. Aluminum chloride, neutral salt. Since it's a salt, it is aqueous. Still not balanced, right? How do you balance? Let's start off with hydrogen. Okay, if you put two hydrogen, you are in trouble. Let's start. What do you do? Two hydrogens are here. AlCl3 is here. Let's put two here. Then let's put what? AlCl3. Let's put two aluminiums here. You have six chlorines. AlCl3. Altogether, you have then what? Three hydrogen gases. Why? Because there are three hydrogens. 3 times 2, 2. Yes, kind of a tricky one to balance, right? But you should get used to it. Right now, it is balanced, right? With only practice, only you will get to know from where to start off it. Right? It's just your instinct. Nothing to be taught there. If you have enough practice, you know from where to start balancing it. Now I am doing it with my experience, instinct. When I am looking at it, somehow I get the feeling I should start from somewhere. You get that only with practice. So write the equations, formulas, and balance it yourself. Then you will get the hang of it. It's kind of mathematics plus your instinct, right? You get the feeling like you should start from there somewhere, right? So just about your practice. But otherwise, it will take more time for you to balance something like this. But there are some other methods to balance very complicated equations. But we teach you that only in your A levels, right? Using oxidation numbers, there are some ways to balance them, right? Okay. Give the name of a metal that could be P. Give the name of a metal that could be P. Uh, yeah, very inert, right? Gold, silver, platinum, bottom of the periodic table. You must remember the periodic table, right? Mm. Gold is there, platinum is very inert, silver, right? This is gold, right? Ag, argentus. Latin name is argentus. That is why it is called Ag. This is gold, right? Platinum. Therefore, we have Pt. Orus. Orus is the Latin name, right? No, sorry, this is not gold. This is silver. Ag is silver. Au is gold. Gold is Orus, right? Ag means argentus. So based on the Latin name only, symbols are derived, right? All good. Give a reason why the reaction of Q with dilute hydrochloric acid is not done. Ah, it could cause an explosion. The same thing I asked, right? So as chemist, you must be smart. So that is why you are starting when you are testing chemicals in the lab. You starting off with least, uh, least reactive elements, or you are starting off with least reactive or less stronger reactions, right? You are starting on less stronger reactions, or if you jump into the strongest one, it could be dangerous, right? Okay, you are trying to potentially protect yourself. So that is why, okay, if it is getting reaction very fast, with dilute with water it is getting reacting very fast. Then no need to talk about acid. Definitely it is starting the reaction faster and it could cause an explosion, right? So without thinking twice, they are stopping at that point, right? It could cause an explosion, right? Good. The diagram shows an apparatus used to demonstrate the reaction between aluminium and iron oxide. Magnesium fuse, mixture of aluminium powder and iron oxide powder. Aluminium is there, right? So they are demonstrating a reaction between aluminium and iron oxide. When the magnesium fused is lit, a very exothermic reaction occurs. What is meant by exothermic? They have asked the same thing, right? Ah, what is meant by exothermic? Exothermic means term can, yeah, it is releasing energy. It is releasing heat energy, right? When it comes to energy, there are many forms of energies. Exothermic term means thermal. Thermal means a Latin term for heat. Heat releasing, right? Exo means released. Heat releasing means actually heat means heat energy, right? So it means it releases heat energy. Exothermic or thermal energy. Thermal energy released. Energy released, right? To the surroundings, right? State why aluminium displaces ion. Why aluminium is displacing ion? Very easy one, huh? Very good. In the reactivity series, aluminium is at the top, iron is at the below the I- iron is below the aluminium, right? So if aluminium is here, iron is somewhere around here. So we know by theory, highly reactive elements are displacing least reactive element. Displaced. We are calling it as displacement. So they are displaced. Displaced means what? Removed completely. Yeah. And taken the place. Aluminium has taken the place of iron. This is called displacement. Aluminium taken the place of iron, displacing iron, and aluminium what taken the place, and what happens? Iron has been kicked out from the house. Right now he is with oxygen. It happens, right? Kicked out iron. Right? That is called displaces. The reason is just like in our world also, right? If you have money, if you are rich and powerful, you can kick someone out in the other house and replace you. Same thing here. More reactive, taken the place. Right? Okay. In human world, it's money and power. Here, it's about reactivity series. Displaced ion. Right? Because aluminium is more reactive. Aluminium more reactive than what? You are write it. Than ion. That is short and sweet answers. Right? Very short. Explain why this reaction is a redox reaction. Explain why. Now you must get 2 points. Now we are getting prepared ourselves for an examination. So we are trying to score 2 marks here, 2 points. Keep that in mind. 2 points, 2 marks. Now how are you going to score that marks? Explain why this reaction is a redox reaction. Why? Yes. You can tell aluminium gets oxidized. Remember the term, right? Aluminium is getting oxidized. Gets oxidized. Or you can call it in one word, lose electrons. Iron, there are two, we have to just talk about two elements. Iron gets reduced. Gets reduced, right? Passive voice. Gets reduced. Not reducing, gets reduced. Right? He is getting reduced. Not the other way around, right? Iron reduced means, it means iron is reducing aluminium. That is something else. Gets reduced. Right? Iron gets reduced, takes electrons. So you can take takes electrons. When both these things are happening at the same time, for a reaction to happen, both these things must happen together at once. They exchanging electrons. It is called a redox reaction. Right? All good. Okay. Right. I'll move on to the next one. A diagram represents an atom of element Z. Z is not the symbol of element. Right? Okay, now remember that. They are talking about it also. Z is not the symbol of the element. Give the number of the group to which the element Z belongs. Give the number of the group to which the element Z belongs. Ah, what is the answer? Okay, how did you decide on that? Very good. How did you decide? Very good. Outer shell, valence shell. We are calling the outer shell the valence shell. The valence shell contains two electrons. Valence shell electrons are equal to the group number. That is how The periodic table is arranged, right? Then what about period number? There are something called period also. Group or columns. Number of shells. Number of shells, right? Number of shells. Period number is equal to number of shells, right? Ah. So it is group 2. They are asked the reason, right? Okay. Okay, I'm going to give you a small task now. Find what this is at this. Now you must all have the periodic table with you in the chemistry class. At school, at the class, it is your Bible. Remember, for a chemist, periodic table is a Bible. If you can remember it, chemistry is going to be walk in the park, right? But you want to be smart, right? Group wise. Now, if you ask me any element, I can tell you where that element is. If you want to be good in chemistry, if you want to enjoy chemistry, memorize the periodic table group wise, right? If you can do it, it is your Bible, right? So if you know the Bible, no one can, like, yeah, you have the guidance inside you, just like that. If you know, for a chemist, our Bible is a periodic table. If you know where each element is, which period it is, chemistry is going to be a walk in the park. You should have the map in your head. It will be very easy for you to master chemistry at your A levels. But by the time you go to your A level class, it will be too late. You don't have much time to memorize it. So start memorizing it now, right? Okay, I'm going to do a small task. Find what this is at this and send me your answers. Magnesium. Okay, how did you arrive your answer? Why you are telling it's magnesium? Tell me. Why it is magnesium? Very good. Right? So if I ask you find what this element is, you go to your periodic table. They have given us. Now here period number is equal shell number 1, 2, 3. You go to a periodic table. Now I don't need it because I can remember now. I know where each element is. I will give you the proof, right? So they say it's which period? You are saying it's magnesium. Let's see. 1, 2, 3. I'm going to third period then. Three shells down. Three shells. One, two, three. This is the period, right? Here you have the hydrogen, right? Now, here you have the hydrogen. Right? Hydrogen, helium. Third shell. One, two, three. Third period. Group number is 2. Why? There were 2 electrons in the outer shell. Ah, 2 electrons. One, 2, 3. So, group number is 2. It doesn't take much time, right? Like a crossword puzzle. One, first one is hydrogen, right? Remember that. Here it's hydrogen is placed here. Hydrogen must come here, right? Hydrogen, one, two, three. Second group, you have magnesium. Yes, magnesium is the answer. So you don't need any of those things if you can remember it, right? Magnesium, right? First group, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. If you ask me fifth one, nitrogen, phosphorus, arsenic, antimony, bismuth. If you ask me the last one, helium, neon, argon, krypton, xenon, radon. Third one, boron, aluminium, gallium, indium, thallium. Fourth, carbon, silicon, germanium, tin, lead. Seventh, fluorine, chlorine, bromine, iodine, astatine. right? That's it. Second one, beryllium, magnesium, calcium, strontium, barium, radium, right? So that's all. You are completely told all the, I told all the elements in the periodic table except the D block. You are learning D block in the A levels. Even that you can remember, right? Scandium, titanium, vanadium, chromium, manganese, ferrous, nickel, cobalt, zinc. Likewise, if you know, if you can memorize logically, chemistry is going to be very easy. Right? So before you get into A levels, if you have a plan on studying chemistry, right now start memorizing group wise. Right? Anyway, give the formula of the compound that forms when Z reacts with fluorine. Ah, very good done. Now you are right. Z as Z. Z fluorine. Right. Okay. For Z, what is the valency? How many electrons or how many bonds it can form? How many electrons it can get shared or removed? Two electrons. Fluorine, what is the valency? How many electrons can be shared or taken? Is it 7 or 1? 1, right now. Taking electron is easier for fluorine, right? Swap. What do you get? Is it 10? F2. Swap in the valencies. That's it, right? Usually, metals are written first. Now, there's another question. Now, usually, metals are, that is the convention, right? Metal is first, non-metal is next. Non-metal, right? Non-metal, usually there are no two metals. Non-metal, usually uh, oxygen is written later. That is why we called H2O. Both are non-metals. Usually oxides are written later, right? If they both are non-metals, usually it contains oxygen. Oxygen is written later. And ammonia, NH3, in this case hydrogen is little later, right? So you will get used it later, right? I don't want to confuse you, but remember metal and non-metal. Metal is written first. 1 mole of Z contains this number of atoms. Calculate the number of electrons in 1 mole of atom of element Z. Give your answer in standard form. Yeah, 1 mole of Z contains this. Give you a number of give the number of electrons in 1 mole of atom of element Z. Oh, come on, that's just mathematical, right? Hmm. How do you find it? 1 mole contains this number of atoms. One atom contains of Z how many electrons? One atom. One atom of Z contains how many electrons? 12, right? How do you know? Yeah, it is given, right? 2, 8, 10 plus 2, 12. One atom contains 12 electrons. Then 1 mole means what? We call it in the A levels. You call this is invented by someone called Avogadro. We call it an Avogadro's constant, right? So one atom contains 6.0 into 10 to the power of 23 atoms. Then each atom 12. I will get the answer, right? So it gets as 7.2 into 10 to the power of 24, right? Isn't it? 7.4, right? I did it manually. Yes, 7.4 into 10 to the power of 24. Okay. Give your answer in standard form, right? In the standard form, it must be written in what? Only one decimal point. No, not one decimal point. There can be only one tens, right? You can have one tens value. In mathematics, you are learning tens, right? A sample of Z contains three isotopes. What is an isotope? What is an isotope? Very good. Or you can call it as proton number and neutron number. Together it is called nucleon number, right? It is another way. Some books you will see nucleon number. It contains different nucleon numbers, but they have same number of protons. But they are given the same name because the name is given based on number of protons, right? The name of an element is given based on the number of protons. So different same, that is why we call it as same element. Although they are the same element, their masses are different. Why? Because their neutrons are different, right? Neutrons affects the mass. Same element with different masses, relative atomic masses. There are two definitions. Same element with two different relative atomic masses, or and two elements having same number of protons or different number of neutrons, right? So you can write your answers in two different ways. Both are correct. Isotope, it is easy, right? Relative abundance, number of neutrons, relative abundance. Okay, okay. Write the information in a table to calculate relative atomic mass. What is the formula? Now, relative atomic mass means actually, I'll tell you a small hint. It's the average mass. Relative atomic mass means average mass of different isotopes of the same element, right? Different masses of different isotopes of average mass of different isotopes of same element, right? Why? For any element there can be only one relative atomic mass, but same elements are there in different masses. Number,